Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. So, in this video, I would like to revise flexibility method analysis of beam. Okay, we will focus on one redundant beam first. Okay, so let's say we have one beam. Okay, we have one beam like this. Fixed roller here. So this is A, B, A, okay, B here. This is C, and D. Okay, from A to B, this beam is subjected to triangular load. Triangular load. Okay, it's triangular load. Okay, let's say the value of this triangular load is 50 kilonewton per meter. Okay, so at D is subjected to a vertical load of 200 kilonewton. Okay, and there is a moment at C, moment clockwise. Okay, this moment is 350 kilonewton meter. Kilonewton meter. Okay, let's say the distance from A to B. The distance from A to B. Okay, let's say the distance from A to B is 2 meter, and then B to C is 3 meter, and C to D is 2 meter. Okay, the EI for AB is EI, for BC is 2 EI, and for CD is EI. Okay, so for the first part of this video, I would like to explain how we draw, okay, the possible primary structure. How many possible primary structure, and the redundant of each primary structure. Okay, so by looking at this beam, the beam is okay, the beam has one redundant. Okay, we calculate based on the difference between number of unknown reaction and 3 equilibrium equation, because only 3 can be solved using equilibrium equation. Okay, so the simple way to calculate the redundant is DOI. So we total all the unknown reaction, and since we have one fixed one roller, so there are 4 unknown reaction. Okay, we minus by 3 because only 3 can be solved using equilibrium equation. Okay, 4 refers to number of unknown reaction. This 4 refers to number of unknown reaction in the system, in the beam. Okay, and 3 refers to the 3 unknown reaction that can be solved using equilibrium equation, 3 equilibrium equation. So we have 4, but only 3 can be solved using equilibrium equation. So this difference give us number of redundant in the system. Number of redundant in the system, and this is equal to 1. This is equal to 1. Okay, and redundant is the problem. Redundant in the system is the problem, because if we have 3 unknown reaction in the system, we don't have problem. But now, since we have 4 unknown reaction and only 3 can be solved using equilibrium equation, so we have 1 redundant. We have 1 problem called as redundant. We have 1 redundant. So what we need to do is we have to solve the problem. We have to solve the problem. Again, so looking at the beam, there are 4 unknown reaction. There are 4 unknown reaction located at A. At A, A is fixed. A is fixed. There are 3 unknown reaction: AX, AY, and MA. Plus we have one roller at C. One roller at C. So we have we have 4. We have 4 unknown reaction. We have 4 unknown reaction. Okay, these 4 unknown reaction, okay, we cannot solve using equilibrium equation, because only 3 can be solved using equilibrium equation. That is why uh, the simple way to determine degree of indeterminacy is by finding the difference between number of unknown reaction minus 3. These 3 means 3 unknown reaction that can be solved using 3 equilibrium equation. So we have 1. We have 1. So the total is 4. 3 can be solved using equilibrium equation. So we have 1 redundant. So 1 redundant is the problem. 1 redundant is the problem, means that we have to solve the redundant, we have to solve the problem, we have to solve the redundant. So once we solve the redundant, means once the redundant is calculated, we can solve remaining 3 unknown reaction using equilibrium equation. So we have to find way to solve the problem. The problem is the redundant. Okay, how to solve the redundant? Okay, redundant is the problem. Redundant is the problem. Redundant is the problem. So we have to solve the redundant. So we have to solve the redundant. Solve the redundant. So how are we going to solve the redundant? How are we going to solve the redundant? Okay, we will solve the redundant using compatibility equation. Okay, we will solve the redundant using compatibility equation. Compatibility equation. And compatibility equation is actually the equation that we derive from principle of superposition. So the basic principle that we use to solve the problem, to solve the redundant, is called as principle of superposition. That is the principle, the base. Okay, so how to solve using compatibility equation? Actually, compatibility equation is based on displacement. At redundant position. So from the compatibility equation, we can solve for the redundant. Okay. So, and this is based on the displacement. Okay, based on displacement located at the redundant position. Okay, so we write compatibility equation based on displacement that is located at the redundant position, So means that after we identify number of number of redundant in the system, we know that we can only solve the redundant using compatibility equation. Okay, but in order to do that, we have to we have to choose the redundant. So always remember, for one redundant we will have two possible redundant. For one redundant we have two possibility. Okay, for beam we have to recall back the determinate beam concept. So there are two types of determinate beam. It is called as cantilever beam. The beam with cantilever end, there is one end is cantilever, one end is fixed. It is cantilever beam. This is determinate beam. And we have another one that is called as simply supported beam. That is called as simply supported beam. So in simply supported beam, it will have one pin support, one roller support. One pin support, one roller support. Okay, these two types of determinate beam, the determinate beam that we call as primary beam. Primary beam. Okay. So in order to get cantilever beam, means we have okay, and we remove roller at C. We remove roller at C. So this is A, B, C, and D. In order to get cantilever beam, so we remove roller. So the roller that we remove is CY. Okay, means that we remove CY. So CY is the this will occur where we remove CY. Cantilever beam will occur whenever we remove CY. We remove roller. At roller, there will be CY. So to get cantilever beam, the one that we remove, the reaction that we remove from the system is the roller CY. So this is cantilever beam. Loading is there. The loading is there. Okay. And we remove roller at C. So the one that we remove is the redundant. So in this case, this is possible. This is called as possible primary beam. This is possibility number one. Possibility one, is cantilever beam. Possible primary beam, a cantilever beam. Cantilever beam. For getting a cantilever beam, the redundant is CY. So this is the redundant. Okay. So the diagram of the primary beam is like this. The diagram. The primary beam, it is a cantilever beam subjected to all external loading. The one that we remove is the roller at C and roller at C. So CY is the redundant. Means that for having this, so the redundant position is located at C. So in the compatibility equation, we will determine all vertical displacement at C in order to calculate CY, because we will focus on the redundant position. we will focus on the redundant position. Okay, this is when cantilever beam, uh, cantilever beam is the primary beam, means that we remove CY, and the one that we remove is the redundant. Okay. Okay, this is possibility number one. We will have possibility number two, because we whenever we want to solve the redundant, we will analyze determinate structure, determinate beam. So we have two types of determinate beam. Remember, we have uh, we have cantilever beam. This is cantilever beam, and another type of determinate beam is called as simply supported beam. Simply supported beam. Okay, in order to get simply supported beam, since at A is fixed, roller at C, so we have to have one pin and one roller, so we have to remove moment at A. So once we remove moment at A, the fix become pin. Once we remove moment, so we have to change the support condition. We have to change the support condition. Original, it is fixed at A. So to produce or to get pin support from fixed to pin, we have to remove moment at A. We have to remove moment at A. So when we remove moment at A, the beam is now primary beam. Okay, primary beam under the type of simply supported beam. Simply supported beam. So we have possibility number two. Possibility number two, so we have the beam. Okay, loading is there. Okay, now we have to change fixed to pin at A, and we remain roller at C, because B, C, D, this is a simply supported beam. Simply supported beam is a determinate beam. Okay, so we having this, we actually remove moment at A. Moment at A. So in this case, redundant, the redundant is MA. The redundant is MA. Okay, the redundant is MA, and the primary beam is a simply supported beam. So possible primary beam is a supported beam. Okay, so the redundant occur at position A. The redundant occur at position A, and since the moment is the redundant, means that the displacement is the rotation at A, or rotational displacement. Moment, the pair of the moment is rotation. The pair of the of CY is delta, displacement, vertical displacement. Pair of MA is rotation. Rotation at A. Rotation at A means that when we write the compatibility equation, we have to focus, we have to determine rotation that is occur at A position. At A position. Okay, so this is actually the two possible primary beam. Okay, for this beam. So this original beam, the beam has four unknown reaction, one redundant in the system, and redundant is the problem. So means that we have to solve the problem first. So how to solve the problem? We will solve the problem, we will solve the redundant using what we call as compatibility equation. compatibility equation is actually we derive from principle of superposition, and it is actually based on the displacement occur at the redundant position. And in order to solve for the redundant, so we have to remove redundant. So whenever we remove redundant, okay, we have to make sure that the beam after removing redundant, we call is primary beam. Okay, we have to make sure that the primary beam is determinate, the primary beam is stable, and in the primary beam the loading is there, the external loading remain, external loading remain, we just remove the redundant. So if CY is the redundant, it means that we have cantilever beam as redundant beam, as primary beam. If CY is the redundant, the cantilever beam is the primary beam. And we have another option, if moment as the redundant, moment at A, the beam or the primary beam is simply supported beam. Okay, so there are two redundant position. The first pair is the first one is position. The position is at C, and the second one, the position is at A. Okay, so in order to solve this beam, we just need to choose only one. Either we want to choose CY as redundant and we solve CY first, and after that we solve the remaining three reaction at fixed end, or we can also solve this problem by choosing MA as redundant, and uh, we will calculate remaining three unknown reaction at pin support, pin support and at roller support. Okay, so of course for each redundant chosen, we will have a redundant beam or redundant system, and redundant system will follow the type of primary beam. For example, if CY is the redundant, so we actually will get the redundant beam as this, CY as the redundant. So remain cantilever beam means both primary and redundant cantilever beam, and we will apply a unique value of CY. So this is how the redundant beam look like. Okay, and for cantilever beam, we will remain the simply supported beam, and we will apply more representing redundant system. Means that if CY is the redundant chosen, we will solve the primary system and the redundant system, and both are cantilever beam. If MA is the redundant, the primary beam is simply supported beam, the redundant beam also simply supported beam. So we will solve the reaction, writing moment equation, and then calculate displacement. Okay, based on this simply supported beam. Okay, so we will move to part 2 of analysis in the next video. Okay, thank you very much. We will meet again in the next video.